This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day and welcome to IAQ Radio Plus. It's episode 695, and this week we honor and memorialize Hal Levin, an IAQ pioneer. We have remastered and added photos to part 2 of his interview from 6/18/2010. And this is another great remastered show from the IAQ Radio archives. Before we get started, let's thank our sponsors. They're the reason we can continue doing the show. And don't forget about afterthoughts.iaqradio.com, sponsored by First On Site. IAQ Radio marquee sponsor is First On Site at firstonsite.com. IAQ Radio association sponsors are ACGIH, the American Conference of Governmental Industrial Hygienists at acgih.org. AIHA, the American Industrial Hygiene Association at aiha.org. IICRC, the Institute for Inspection, Cleaning, and Restoration Certification at iicrc.org. The Restoration Industry Association, RIA, at restorationindustry.org. The Environmental Information Association, EIA, at eia-usa.org. IAQ Radio industry sponsors are AEML Laboratories at aemlinc.com, Particles Plus at particlesplus.com, TSI Inc. at tsi.com, Tramex Meters at tramexmeters.com, and Healthy Indoors Magazine at healthyindoors.com.
Okay, our guest this morning is Hal Levin. He is a research architect with Building Ecology Research Group based in Santa Cruz, California. Mr. Levin has conducted research and consulted on building impacts on occupant health and comfort, as well as on the larger environment. Since 1978, his work is focused on the integration of knowledge about indoor and outdoor air pollution, as well as other risk factors, into the design, construction, and operation of residential, educational, and commercial buildings and communities. He has contributed to the design of many award-winning buildings, including the design of ventilation systems, building material selection, energy conservation, and total environmental quality. He has contributed to the scientific and professional advancements in the fields of life cycle analysis and risk assessment as indicators of the sustainability of building designs and practices. He coined the term building ecology in the late 1970s and first published an article by that title in 1981, which focused on the dynamic and interdependent relationships between buildings, their occupants, and the larger environment. His list of clients includes governments, industry, and private individuals on 5 continents. Hal, thank you for joining us on IAQ Radio.
On the last show, we discussed a little about your past, and you gave us your definition of, building ecology. You also stated early on that you had found that architects and engineers were just too busy to learn about indoor air quality issues, and basically they just wanted you to tell them what to do. Can you tell us a little more about how you have provided this type of consulting service when working with new construction or on renovation projects?
Yeah, basically, most of my clients, way back when most people didn't recognize that indoor air quality could actually cause problems, were owners of buildings or architects or engineers who'd been involved in a major problem in a building, with a lot of complaints about indoor air quality. And the owner or the architect, someone, usually either being sued or having a problem, would say, we better find somebody who can help us with this. And indoor air quality consultants were, few and far between. And I knew a little bit about it. I started looking at it in 78, and people would call me and say, I asked, and, everybody said I should call you. And so how do you work? And architects are used to having a bunch of consultants on a project, electrical, a mechanical consultant, a structural consultant, a lighting consultant, a acoustic consultant. And generally, the architect designs the building, and he sends it to these consultants and asks them to mark it up and tell them what they ought to do for each piece that the consultant specializes in. But because my concept was one of the dynamic interactions of all of the different aspects of the building, what I did, and I was really making it up as I went along, was said we really need to get the whole design team together and the owner's representative, and we need to talk about what the issues are that might be of concern in this building and how each of our concerns affects the others. Today, this is a big kind of buzzword in architecture and design, sustainable or green design, called integrated design. But at that time, it was just sort of obvious to me that that was what you had to do to properly address it. So we would have a meeting like that, and once everybody's met face-to-face, then you could deal with each other much better by phone or sending a fax, or, you know, we didn't have the internet in those days, and we could progress. And over the years, that's evolved to where I would tell the architect, you need to identify somebody in your office who's going to be your indoor air quality point person, and I'll work with that person, and we'll train that person, and we'll basically work me out of a job, except when something becomes too complicated or over the head or outside the knowledge of that individual. So that's pretty much how it's evolved over the years.
How you've worked on a lot of interesting projects, and there are probably a couple that we would like to touch upon. You know, the Waterside Mall and the clean space in Crystal City. I think a lot of the listeners may not be aware that the Environmental Protection Agency had issues of indoor air quality in their buildings, and employees moved out. Can you tell us a little bit about your experience there?
Yeah. The Waterside Mall was originally built as a housing project in Southwest Washington, and was converted to an office space, and it had a shopping mall integrated into it. And it was one of the three spaces that EPA occupied, the Environmental Protection Agency, occupied as its headquarters back in, I know at least as early as the early 80s, I think the late 70s. I'm not sure when they moved there. In 1988, they had some new carpet installed in the building, and a lot of the employees complained about symptoms and associated them with the carpet. And a lot of them refused to come back into the building. And I guess I was reasonably well known to that community. I had been consulting to EPA's Indoor Air Program Office for, maybe 3 or 4 years at that time. And some of the employees said, you've got to get Hal Levin involved if we're going to move into this new space that you've created for us out in Crystal City. Crystal City is just north of what was then called National Airport, now called Ronald Reagan Airport. And there are a lot of office buildings out there, and EPA was progressively occupying more and more space there. The administrative division of EPA took one space on the second floor of this building and set it aside for the 30 employees that refused to go back into the Waterside Mall. And those employees asked to have a meeting with me. We met in a church, actually, not far from Waterside Mall. And I had already been out to Crystal City to see the space, and it had operable windows. It was the end of the building, so it had 3 different orientations, and it was not really a very clean space by indoor air quality standards. It had a lot of particle board cabinetry and a lot of problems that I won't go into details on. So I met with these employees, and I said, the space has operable windows. It's on the second floor. It's near a busy intersection. There's some landscaping around the building right there. How many of you want to open the windows? And half of them raised their hand. And then it said, how many of you don't want to open the windows? And half of them raised their hand. And that was a really accurate prediction of what happened to that space, because only half of the 30 ever ended up working in that space. They did clean it up according to some instructions that I gave, but it certainly wasn't an ideal space for anybody, let alone people who were sensitive to indoor air pollution.
What about this PCB contamination in a 26-story office building in San Francisco? What was the source of the contamination there?
Well, what we didn't know at that time, but EPA found out not long after that, was that there was a lot of leakage from fluorescent light ballasts that were manufactured before 1978, and almost all office buildings had some PCB in the air from electronic devices. Even houses, electronic devices in kitchens had some PCBs as insulating material in their electronic components. But the building in San Francisco had its transformers in a vault under the sidewalk adjacent to the building. And it was an interesting coincidence that the race from the bay to the ocean in San Francisco that takes place every year, called the Beta Breakers, had just started when this thing exploded on a Sunday morning. And so there were a lot of news teams there and TV cameras, and so they got some really good pictures of what happened. The conduit leading into the building, into the sub-basement where all the power equipment was, brought a lot of that smoke and contamination into the sub-basement, and then the building was divided. There was one system, that ventilation system, served the lower 7 floors and the sub-basements, and another one that served the upper portion of the building. And the one serving the lower portion of the building was operating at the time this happened, so the smoke and the PCBs, and it turned out some dibenzofurans, were carried in and distributed throughout the lower 7 floors of the building, which were subsequently closed and remained closed for about 9 months while they were completely gutted and cleaned up. I was brought into the building by a federal government agency that occupied the 21st and portions of the 23rd floor, and their employees were very valuable to them, and they wanted to make sure that nobody moved out because they were afraid of the contamination. So they hired me and asked me to go in there and measure the PCBs and determine what the level of hazard was. And as a result, we did discover that there were levels of PCBs on the 21st floor that exceeded the NIOSH criteria for PCBs, which was 1 microgram per cubic meter. And that was not established as a safe level. It was established as the lowest level that was practical to measure with industrial hygiene techniques. And that level was exceeded in a couple of our samples on the 21st floor. That agency eventually moved out of the building. Interestingly, we measured in another building where they were temporarily housed as a background, and we also found rather high levels in this other building that wasn't known to be contaminated, but it had been constructed in 1964. It had fluorescent light ballasts, and now we know it's history. Now almost every building with fluorescent light ballasts from that era are going to have PCB in the air and on surfaces. PCB is not very volatile, so most of it ends up in dust and on surfaces.
Quick question for you, Hal. I've heard different stories about the actual risk of PCBs, and I'm just curious, in your research on the issue, I assume you did quite a bit of research at that time, were you able to find anything definitive about what type of risk it might cause for people?
Well, I'm not a health scientist, so, it's not my expertise, but you're right. I did definitely look into it. We simply follow the NIOSH guidance on it, which required, when we discovered this, we got these high levels on our first set of samples. I had to make my crew, I had 3 guys sampling up there. They had to put on the moon suits and the independent breathing devices, and they had reopened the building. So they're riding up in the elevator with all these employees, and they're, dressed in a hazardous cleanup manner. But the concerns were liver damage, a lot of chlorinated compounds when they are exposed to high temperatures form dioxins and furans, and we did do analysis for dioxins and furans. They're pretty expensive at that time. It was $1,000 a sample, but we did find some furans in a ratio that was reasonable in terms of what data there were on the level of furans and dioxins you might find in PCBs. And there's a concern about cancer with the dioxins and the furans. PCB is very complicated, and the dioxins are very complicated. There are a lot of different congeners, and some are much more toxic than others. There continues to be a lot of controversy today because, at least in Europe and to some extent in the U.S., PCBs have been found in sealants that are used in buildings, including schools. So the concern about PCBs is not gone, but the major health hazards are those that are shared with a lot of chlorinated compounds, and that's about liver damage and chloracne skin manifestations.
I've got to run to the airport here shortly, and actually I'll be coming through San Francisco. I noticed you've done a lot of work in and around that area, and a lot of it, or at least you've done a good bit with homes that had been either had pesticide or termiticide misapplications, I guess. And I'm curious because I've got a friend dealing with this in North Carolina right now. What types of issues did the people in those homes have, and what type, how did you go about trying to figure out what those issues were coming from? I mean, did they know there was a misapplication, or is that something you had to search out?
Well, they didn't know there'd been a misapplication. They simply knew that after their house was treated, they began having symptoms. And from my perspective, what was going on, termite control companies have to be licensed, and the products they use have to be registered with the EPA. But the licensed operator hires a bunch of workers to go in and do the work, and there's a kind of more is better attitude, because if somebody hires you to do a termite prevention project, then you don't want them calling you in a year and saying, hey, I've got termites again. Why didn't you guys do a better job? So there's a tendency to overuse. There are a lot of documented cases of underdilution, underdilution of the mixtures. We're talking about pentachlorophenol and later chlordane and chlorpyrifos, basically in the period of the late 70s through the early 90s. And it's sort of an attitude of more is better. There's also the problem, I don't know if you've ever put on a Tyvek suit and crawled underneath a house in a crawl space, which, in California, primarily we don't have basements. It's mostly crawl spaces. And you get under there, and it's hot, and you get sweaty, and it's uncomfortable. Sometimes the clearance isn't very good. And so a lot of the applications were done from outside the crawl space in through the vents with a long rod. And instead of treating evenly over the area of the crawl space, they put a larger amount in one location near the perimeter that they can reach easily. So it's a problem of practicality and a problem of kind of CYA in order to not get callbacks. And perhaps a problem of hiring labor that isn't trained the way the operator, him or herself, is trained. And I think finally there were magazines that were sold to this industry in that era that were full of articles saying how all these chemicals were safe. You know, don't worry about it. I drink it for breakfast.
Well, Hal, what kind of complaints did the folks have that were in the homes? What type of health issues were they showing?
There were respiratory problems. There were I did an investigation of one case where chloracne in the children. It turns out because these compounds like PCBs are not very volatile, they end up on surfaces and in dust, and children tend to have much higher exposure than adults through skin contact and also through inadvertent ingestion. You know, a small child puts everything in their mouth. So in this case, which was in Omaha, Nebraska, the children had something like 5 times the levels in their blood and urine that the parents had. This was a house, it was a kit, a log cabin kit that the father bought, and it came on a truck, and you assembled it, and the logs were pressure treated with pentachlorophenol, and the children, both of the sons, young children, I think less than 10, became very ill as a result. Their exposures were huge because these logs were pressure treated with pentachlorophenol. There was a lot of pentachlorophenol in the house.
Good. Well, Annie, it's halftime. Let's go ahead and sell soap.
Our marquee sponsor is First On Site, your trusted full-service disaster recovery and property restoration company at firstonsite.com. Association sponsors are ACGIH, Advancing Careers of Professionals in Environmental Health, Industrial Hygiene, and Safety, interested in defining their science. ACGIH.org. AIHA, Healthy Workplaces, A Healthier World. AIHA.org. The IICRC, a nonprofit standards development and certifying body for the cleaning and restoration industry. IICRC.org. Industry sponsors are AEML Laboratories. Free shipping, great pricing, same-day results with no rush fee, AEMLINC.com. Particles Plus, feature-rich particle counters and air quality instrumentation. Count on us, particlesplus.com. TSI Inc., an industry leader in precision instrumentation for monitoring indoor air. Learn how to expand your IAQ investigations, TSI.com. Tramex Meters, developing modern dynamic moisture meters and humidity monitoring systems since 1974. TramexMeters.com. And Healthy Indoors Magazine, a free online magazine for industry professionals and consumers. HealthyIndoors.com.
Okay, Hal, you've been successful in getting to work with architects and engineers early on during the design of a project to ensure that IAQ is taken into consideration throughout the project. What tips can you give the next generation of indoor air quality professionals to help them get a seat at the table from the beginning of a project?
Well, as I said earlier, most of my early clients were organizations that had been involved in a serious IAQ problem or supposed problem, and many of them had been sued, and they learned their lesson the hard way and decided they better have an indoor air quality consultant. The world's a different place now. I think a significant fraction of building owners and architects and engineers recognize that indoor air quality is an issue, and I'm not sure that my history is so relevant today. I think what's going on today, obviously, is the movement toward green buildings, and indoor air is almost always considered an important part of a green building. And the majority of owners who are interested in a green building are looking at the LEED rating system or some other rating system as a way of getting recognized as having a a green building. So while I'm not a particular fan of the LEED rating system, I don't think it's very rigorous in terms of indoor air quality, as well as a number of the other areas that it treats. Certainly, being familiar with the requirements of the LEED rating system would be a prerequisite for someone to be involved in the vast majority of the projects where a consultant might be brought in for indoor air. My work today, when I get involved in buildings, tends to be with so-called green designers who realize that their client wants something more than just a LEED rating. They really seriously want good indoor air quality, and they have enough concern to be willing to pay for a consultant that goes beyond just the point shopping that is done in most LEED projects. You can get a LEED Platinum rating without getting any points for indoor environmental quality if you get enough points for other things. So there isn't a single answer to your question. I just think becoming more and more knowledgeable about the various contributors or potential contributors to indoor air pollution and the solutions. And, I've never advertised, I've never marketed my services. My work has always come to me, so I'm probably not the best one to answer the question that you've asked.
Okay, well, speaking about LEED, that program has gotten some bad publicity recently, in particular for encouraging the use of new products without having done enough research to find out how these products will work in buildings over time. Do you think that this criticism is legitimate or not?
I think I would restate the criticism if you're referring to that report from the Environmental Health Institute, I think at Yale. It was that the products use chemicals that haven't been sufficiently researched. What we're seeing as emissions testing is becoming more common, and lists are created of certified products with respect to emissions, is that manufacturers are reducing the level of those VOCs in their products that have traditionally been identified as hazardous and that might prevent them from getting the certification or the label that they're looking for, and they're replacing them with new chemicals. And those new chemicals are coming into use all the time, and we know very little about them. I think that was one of the criticisms from that report, and then the other was simply that you could, as I said a minute ago, get a platinum rating on a building without getting any points at all for indoor environmental quality. The response from the defenders of LEED was, well, you have to meet standard 62, and that provides good indoor air quality. And my response to that is standard 62, ASHRAE standard 62, is a minimum code standard. It's not intended to deliver a high quality indoor environment. It's intended to prevent a problem in the indoor environment. And even at that, its focus is on perceived indoor air quality, not a rigorous analysis of all the chemicals that might be in the space.
Well, thank you for that answer. We hear a lot about damp buildings and lately VOCs, volatile organic compounds, and tight buildings. What other IQ problems do you feel don't get enough attention today?
Well, I do believe that moisture is a major issue, and that any building with leaks or with excess moisture accumulation or evidence of past moisture accumulation really need to be addressed. And my sense is that we still don't understand completely what moisture does. There's been a big focus on mold because so often you can see it, but I suspect there may be a connection to bacteria and or viruses that are also related to damp buildings, and I'm hopeful that we'll learn more about that in the coming years. I think the biggest unmet need in terms of indoor air research and action to prevent health problems really is in the area of semi-volatile organic compounds, things like the pesticides we were discussing before. The fire retardants, PCBs, are there really to prevent fire. And there are flame retardants in furnishings that there's increasing concern about the health effects of exposure to these flame retardants, and particularly now plasticizers, the phthalates that are added to so many plastic materials, including flooring and wall covering, and also a huge number of consumer products, so that the whole population is being exposed to a lot of these semi-volatile compounds, which, as I said before, they stay around for a long time because they're not very volatile. They cover every surface in the building eventually, and especially children are very highly exposed to them. And, of course, this is the worst time in our life to be exposed to a toxic chemical, is when we're very young. So I would say SVOCs are going to be a major topic in coming years. We're going to see them included in emissions testing. We're going to see more and more research on SVOCs. And, in fact, there have been workshops recently in Europe and just 2 weeks ago in China, and I've been involved in organizing a workshop for the Indoor Air Institute on SVOCs, together with EPA, working with the toxicologists to bring information we have about exposure to the toxicologists so they can target their research on those chemicals to which we're really most exposed.
Thank you. What part of indoor air quality or building science are you most passionate about today, Hal?
Well, that in a sense hasn't changed. It's building ecology. It's putting it all together. But what I see happening now for the first time really is some very serious science from outside of the indoor air community is being brought to apply to the indoor environment. And that's being done by the Sloan Foundation in New York, which has funded a lot of grants, several $1 million, to what are people who are microbial ecologists, people who work in tropical jungles and in marine environments and in other environments. They're getting grants to look at the microbial ecology of the indoor environment. And the purpose Sloan has is to get enough information to make it obvious to the federal government, EPA, and the National Institutes of Health that they should be looking at the microbial ecology of the indoor environment. And what the next step in this is to bring together the microbial ecologists with the building scientists and the indoor air scientists and really see the whole building as a system, because you can't just study the microbial ecology without understanding the whole building ecology. So for me, it's much more high-quality science at the detail level, but with a clear connection to the understanding of the whole building as a system, the dynamic interdependence of the various components of the building.
You know, speaking of research, where do you see the biggest disconnects between research and the practice of indoor air quality today?
Well, indoor air quality isn't any different from a lot of other aspects of the building. There's generally about a 20 to 35 year delay between when the science happens and when it makes its way into codes and regulations and standards and guidelines. I see an awful lot of use of techniques that have been discredited by science in terms of building investigations, misuse of CO2. I don't know if any of your listeners are still using settle plates to try and characterize the microbial indoor environment, but it really is. There's a gap, and IAQA and the IAQ are both organizations that are formed to try to bring the knowledge of science to the practitioners. But the biggest gap is we don't know how to best deliver that knowledge to the people who need it when they need it. And of course, your show is one vehicle for that. And there just aren't enough good vehicles for it, and we really don't know enough about how to deliver the knowledge. Hopefully the internet and iPhones and, being able to be in touch all the time everywhere is one remedy for the problem. The other is that the indoor air field is dominated now by commercial activity, and it always will be. I mean, somebody has to pay you to spend your time, or you have to pay for products. But how can we bridge the gap between what is marketable and what makes sense from a scientific point of view? And I think that's the big challenge that we have, without going all the way to regulation, but just delivering knowledge and getting good products out there and teaching people how to use them properly.
You know, you are executive director for ISIAC, which is the International Society for Indoor Air Quality and Climate. What are you doing to help ensure that research and practice get more closely aligned?
Well, as you may know, we have a journal which is primarily about science, but we have an initiative, which is really my initiative, which is try to develop another publication that really will translate the research into practice for our members and for the larger world that are interested in learning what science has taught us about indoor air problems. And a publication, you know, whether it's on the web or whether it's a print or a emailed file is just one approach. Our conferences are increasingly paying attention to the professionals, the practitioners, not just the science, but we are just learning how to do that, and it's something that the board of directors is dedicated to. It's something that I've been committed to for 30 years. When I got into indoor air quality, quite honestly, when I discovered the problem existed in 1978, I thought I would study it for a year, I would teach architects all about it, and I would go back to working on low-income housing. That was in 1978. We still haven't even begun to do what, you know, I had as an ambition at that time. So we all have a lot of work to do.
Seems like the more questions we ask, the more questions need to be asked. Please tell us
the purpose of the best question is one that leads to a better question.
Right. Okay. That's great. Tell us a little bit about the history of ISIAC.
ISIAC was founded during the 1990 Indoor Air Conference, which took place in Toronto. At that time, the leaders of the international indoor air community organized what is known as the International Academy of Indoor Air Sciences, and that was to be by invitation to, I think there were about 70 of us that were the original fellows of the Academy. They saw the need to also have an organization that the larger community of indoor air could join and participate in, and so they decided to found ISIAC. So ISIAC was first organized in Canada, and the secretariat moved around the world. It was in Canada for a while. It moved to Finland. It moved to Italy. Then it moved to Finland. It just moved here to my office a year and a half ago. And we are something close to 800 members strong now, and are expecting growth, significant growth over the next 5 years in our membership.
Let's talk about Scandinavia. Scandinavia, I think, in North America has a reputation for being ahead of the curve in regard to IAQ issues. I know you've been there and worked there. What do you think? Do they deserve that reputation?
Oh, absolutely. The first emissions testing was begun in late 1960s by Ib Andersen, former head of the Danish National Institute of Environmental Health, and Lars Molhav, one of the pioneers of the indoor air field, working on VOCs. And they had tight buildings before the rest of us because of their severe climate, because they're fairly wealthy countries. Sweden dedicates a significant amount of money to building science and building research. And so they had very low air exchange rates. And in the late 70s, or in the 70s, when particle board and plywood emitted so much formaldehyde. They had very high levels of formaldehyde, and they had symptoms, and they figured it out. And they're willing to go ahead and take action there, whereas in the U.S. we have to prove that there's a hazard before we take action. Europe, in general, I don't want to overstate this, but they operate more on the precautionary principle. If you think there's a hazard and you don't have strong evidence that there isn't one, then you take action as a preventive measure.
Okay. Last week we had on Dr. Corsi, and we talked a lot about indoor air quality and this event coming up, Indoor Air 2011 Texas. I understand that you want more practitioners at the show and more interaction between practitioners and researchers. One of our concerns is that they have these 5-day programs, and most practitioners can't get away from their business for a 5-day conference, especially a conference that during a bad economy. You know, we suggested off the air that the conference might have a beginning or end focus on research and practitioner relationship, maybe 2 or 3 days dedicated to practitioners. Any thoughts that you would have on something like this?
I think it's a great idea, and I think in a conference like the Indoor Air Conference or any large conference that lasts for 5 days, you need to organize the sessions so that the similar items form a thread that builds on the previous session. Each session builds on the previous one. So clustering them all at one end of the conference, the beginning or the end of the conference, would make great sense to me. So I think it's a great idea. Was Corsi receptive to that?
I hope. Joe's working on it with him, so hopefully, we can get him to do that, because I know that a lot of the listeners probably don't go because they can't get away, and they'd probably be more likely to go if they could get clusters so that they can kind of get in and get out.
Yeah, and I know that we're working together with Glenn Fellman and IAQA. I think there may be a discount for IAQA members, and that there may even be an IAQA event piggybacked on the Indoor Air Conference. So we're very focused on trying to make it appealing to and useful to practitioners.
What questions about indoor air quality would you like to see more research focused on?
Well, as I mentioned earlier, I think we're headed for a time where we're going to see a lot more work on semi-volatile compounds, particularly the phthalates and the flame retardants, as well as continued attention to pesticides. The SARS outbreak and H1N1 have made everybody kind of bug conscious or concerned about infection and about contamination of a biological nature. And so people are buying a lot of sterilization products or products that claim to sterilize the environment. And the average consumer doesn't know enough to carefully evaluate the side effects of these things. The propellants and even the active ingredients themselves do pose some hazards. So we're going to see more and more people exposed, and I think we'll see more symptoms in response, and I think we'll see perhaps even a lot more federal government research and eventually some regulation to try to protect people from their own good intentions. So the semi-volatiles are going to be a big one. I mentioned the work of the Sloan Foundation, and I'm optimistic that these people are bringing the techniques of analyzing the DNA of microbial contaminants. They're able to do bulk analysis very rapidly, identify a very large number of samples very quickly and very economically. We're going to learn a lot about the indoor environment in terms of microbial components, mold, viruses, and bacteria, that is going to accelerate our understanding of what we're exposed to. And I think we're going to really learn a lot that is of value in terms of protecting people. And there, too, I think the federal government will get involved in this kind of work.
Hal, I just got a text question from a listener, and the question is as follows. Hal did some research years ago on plants and buildings. Most of it refuted Wolverton's claims. Can you ask him to touch on that issue briefly?
Yeah. Well, the briefest answer is go to my website, and you can read, I think, 3 separate posts there. One I wrote in 1992 for a newsletter, and contains a segment by John Gurman, who used to work at EPA. What we found, and I've met Wolverton, I've spoken to him and to the people who worked for him, they were doing research in what we call a static chamber, a sealed box. And it's just not the way you test the dynamic indoor environment. It's a great example of non-dynamic testing. It turned out that the plants themselves weren't removing the VOCs as claimed by Wolverton, but it was the soil, the medium in which the plant was being grown, and there was some activity in the root zone of the plant, but the plants themselves weren't active. And most of the research that's been done in chambers, the so-called emissions testing or sink effect of plants, even if you took the data from that research, even if you believed it, and it's not good research, the removal rate of VOCs is equivalent to less than 1/10 of an air change per hour in the house. Well, even a tight, energy-conserving house through leakage has more than 1/10 of an air change per hour, and that would be if you filled the house with 3 layers of plants. So you couldn't even use the house. It would be full of plants, and the removal rate of VOCs would be equivalent to 1/10 of an air change per hour. So, and then the field studies that have been done have just not shown that plants are effective in removing VOCs. There just isn't any scientific evidence to support it. What happens is that the indoor plant industry and researchers at universities and well-intentioned cooperative extensions, they pick up this information. It's still on the NASA website because Wolverton did his first project on this when he was still at NASA, and it appears to be valid. And it's a kind of a snowball effect or something like that. It's a self-replicating myth.
Well, I'd really like to know how you really feel on that subject. Thanks.
So I'll try not to hold back my feelings.
That's okay. No, I think it's good. Well, it's probably time that we kind of go into the roundup. But before that, I'd like to ask you Joe's question. I suspect he's listening. Tell us a little bit about your house and, what you've done there in terms of energy efficiency. I think Joe wanted to know that.
Well, the most important thing you can do is to pay attention to what you're using and what it uses. When I moved in here, I had a then 25-year-old refrigerator. I bought the best energy efficient refrigerator on the market at the time about 8 years ago, and I saved 5 kilowatt hours a day just by replacing my refrigerator. The same thing, my computer and my assistant's computers are both laptops that use a fraction of the energy of a desktop with a large monitor. So I could go on and on about efficient appliances, but the main thing I've done here is I have photovoltaics on the roof, and I have a solar domestic hot water heater, and so I'm basically paying nothing for my electricity now because the electric company has to buy back my excess production, and what I produce Monday through Friday between noon and 6, they pay me almost 30 cents a kilowatt hour, and what I use or what they pay me the rest of the week is around 10 cents a kilowatt hour. So if I'm very careful about what I do from noon to 6 on weekdays, I end up not having an electric bill. The state of California paid for a third of the cost of my photovoltaics, and the domestic hot water heater, which was here when I bought the house back in 86, was put in 81, and the state of California paid for half the cost of that to encourage energy conservation. So that's sort of the short version.
That's great. I think we're going to move now into our roundup, so just hang on, Hal.
Yep.
I think we're going to go with Dieter first, and then Joe, and I'll do third, and then Hal's going to bat cleanup. So, Dieter, any comments?
Well, yeah, quite a few, and I'll make it short. I think that he touched on a couple of wonderful topics, and I like it. And you just can't jump into a pool and don't know whether it's water or whether it's hot metal. And we are doing that. And I work for a very, very large chemical corporation, and I know what's going on with their toxicology research and this and that. The one thing that bothers me is that we are in the year 2010, and damn it, we knew how to build buildings 2,000 years ago. Needless to say, there was no plastic. That was probably damn good. And I said it on every one of those shows. I grew up with bricks, with wood, and with glass. I didn't know what plastic was until when I was a kid, Bakelite came out, which is a formaldehyde-based plastic. It was the first plastic I've ever seen in my life. Therefore, I don't have asthma and any of these other nasty diseases you get when you are in a tight house nowadays, where everything is off-gassing from everything. But I think we got to watch that. We should watch that and be very careful of what we are doing. Even though the concentrations obviously are not so high that we are killing people, and that is not the idea. When I live in my house, which fortunately I think it has 3 air changes an hour just by the leakage of the house. My house was built in 35 years ago. The research, I think we have done. We know the acute toxicity of all these materials that we are having, and we are at the bottom of the dose-response curve, at the very beginning of the dose-response curve, and heaven knows what is happening down there. I much rather test something at a high concentration and then go backwards. And I said, look, I know this and this is going to happen, and if I go 100 times lower or 1,000 times lower, I don't expect anything. But this type of research, I don't see, and I haven't heard about anything. Everybody says we should do more testing, I haven't seen any good papers that really went into that part of doing research.
Okay. Joe?
Yeah, I just, I'd like to, if Hal wants to comment on Dieter's question, I'd appreciate that. But before, I've got to check in here. Before I do, Hal, I'm curious, in your experience, how have the photovoltaics come along? Are we making good progress on that? I know you're doing well, but how long ago did you put yours in, and how have we come along since then?
I'm not an expert on it. I am a member of the Northern California Solar Energy Association. I get the Solar Age magazine, and I try to keep up to date. I know there's been a small amount of progress. I think what we need is a major infusion of research funding. The potential for photovoltaics is really untapped at this point, and I think that integrating them into the roofing material or the vertical surfaces of a building is probably the wave of the future. There's some products out there that do that. I think the barrier really is scale, and when it gets up to scale, I think we're going to find that photovoltaics are commonplace.
Thanks for that. And I wonder if you could comment on the sustainability of those systems, through the total life cycle, or maybe just touch on that issue with respect to green buildings and some of the more current products coming out, and maybe just talk to listeners for a second about sustainability in general and the life cycle.
Well, specifically on photovoltaics, there have been life cycle assessments of them, and they show that it does take somewhere between 3 and 7 years of use to pay back the environmental costs of their manufacture, transport, and installation. So, there are no free lunches. But there are some things that you can do that, as Amory Levins once put it, it's not a free lunch, it's the lunch they pay you to eat. And that's things like compact fluorescent lights, and now the introduction of LEDs. We're going to find that our plug loads, when we begin really tapping the potential for efficiency and conservation, our plug loads and our building loads are going to be so minimal. We're really going to be looking primarily at the energy required for ventilation, for heating, and for cooling. And so the real challenge is to find ways to do those things more efficiently and at a lower environmental cost. Reducing the sources will reduce the need for ventilation and therefore the need to heat or cool the new air brought in from outside. So if it's all done together, we can really look at a brighter future. And if we learn how to get around without burning fossil fuels in our vehicles, and we don't burn as many fossil fuels at our power plants, we'll have much cleaner outdoor air, and we can have much more natural ventilation without introducing the pollutants from outside into the indoor environment.
Well, Hal, before we conclude, is there anything that you'd like to add? Are there any topics that we didn't touch that you wanted to get into today, or anything you'd like our listeners to know?
I just think that indoor air is, relatively speaking, a new field. We're learning more and more every day about how little we know. We're making huge progress, but we're just scratching the surface. I think we need to be humble. We need to acknowledge the limitations of our knowledge and attempt to continue learning all the time. I think that the members of IAQA and ISIAC are committed to that. I think people who listen to your program are committed to trying to learn. I think as long as we recognize the limits of our knowledge, we can keep moving forward.
Okay. How can people learn more about you and your business? Please give your website, if you could.
Well, my website has a lot of great information on it, and it's accessible to anybody. It's buildingecology.com, and I've invested a lot in creating a very good free resource for indoor air quality and for sustainability. Also, they can visit the ISIAC website. They can think about getting involved in ISIAC and consider coming to our conference next June in Austin, Texas.
What's the ISIAC website, Al?
isiaq.org.
All right. What a powerful thing the archives of IAQ Radio are. Thank you very much also to Hal's widow, Mary Chiara, Rich Corsi, Don Weeks for sending photos, and my thanks, as always, to John. You got to have faith for his usual great job of editing and remixing this special show. I also want to thank our sponsors and, most importantly, our loyal audience. Next week, we're off for Good Friday and Passover, and then March 14th, we welcome Dr. Ji Zhao, PhD, he's the Executive Vice President and Head of Delos Labs. So another great show coming up 2 weeks from today. Please come back and join us for the next episode of IAQ Radio Plus.
For IAQ Radio, I'm Spike Reel saying thanks for listening.